On number 13, we need to get x by itself, so we've got to start moving stuff around. First thing I would do is subtract 3. If I subtract 3 from both sides, I've got square root of 6x plus 1 equals 5. I've got to get x by itself, so the next thing I need to get rid of is that radical symbol, that house. To get rid of the house, you have to square both sides. So if I square both sides, I'll have 6x plus 1, because the house went away, equals 5 squared is 25. If I subtract 1, I get 6x equals 24. Divide by 6, I get x equals 4. So I subtracted 3, I squared both sides, I subtracted 1, divided by 6, and got x equals 4. I ought to plug it back in, or at least do it in my head to make sure everything looks legit. So 6 times 4 is 24, plus 1 is 25. The square root of 25 is 5. 5 plus 3 is 8. Yeah, that's a legit answer. You need to check to make sure your answers are legit, because sometimes you end up getting extraneous solutions, meaning if you plug it in, all of a sudden you're taking the square root of a negative number or something crazy that can't happen. 13 was okay. 14 is a pain in the absolute rear. If I were to see a problem like 14 on the semester exam, I would not work it out. I'm not lazy. I just think it would be faster to plug in the answer choices. So if the answer choices were like A3, B9, or 30, 90, like I would start plugging in the answer choices of which one actually works it out. That's my suggestion. But sad day, they didn't give us any options on the study guide, so we have to solve. So if I add x to both sides, I'll have the square root of 5x plus 4 equals x minus 2. I'm going to square both sides to get rid of that house. So I've got 5x plus 4 equals x minus 2 squared, but I need to work that out. So over here on the side, because I'm out of room, I'm going to do x minus 2 times x minus 2 to figure out what that would be if I folded it out. So that would be x squared minus 2x plus 4. So x squared minus 4x plus 4. Okay, why did we have to FOIL it out? Oh, because I'm needing to like combine my like terms, like the 5x and the 4x need to kind of go together in a second. So that's why I had to FOIL it out. Now when I start to solve, some fun things do happen. So if I subtract 4 from both sides, the 4's die. So I just have 5x equals x squared minus 4x. Now what I would do is move everybody to one side. So I would have 0 equals x squared minus 9x. Someone last period did it a different way, but you know, you do you. If I did this, I could pull out a GCF of x. So I then set each of them equal to 0. So I set this equal to 0, so I get x equals 0. I would set this equal to 0, so I get x minus 9 equals 0, so x equals 9. So I've got 0 and 9 as my two answer choices. And if I wasn't tired of doing math like you, I would plug them back in and make sure they're legit, because sometimes buyer beware, they're not. For instance, on this one of them is not real. They're not legit. Okay, I need to plug them back in. Miss Compton's trying to skip things in life and she can't. That's what the scary thing is. Okay, so I got 0 and 9, and I'm not sure if they're legit or not. I go back to the beginning. And I know there's a problem, because if I plug in 0, I end up getting, so that goes away. Square root of 4 equals negative 2. Well, that's not true. Square root of 4 does not equal negative 2. Square root of 4 is 2. 2 is not equal to negative 2. So 0 is not legit. Goodbye, 0. If I plug in the 9, maybe he's legit. So it used to be square root of 5x plus 4 minus x equals -2. I plug in the 9, so I've got 5 times 9 plus 4 minus 9 equals -2. 45 plus 4 is 49, so square root of 49 minus 9, is that equal to -2? Well, yeah, 7 minus 9 does equal -2, so that one's legit. That is annoying. Wow, Ryan. Really, Ryan? Really? That's funny. Okay, and then I know I just love that I miss all the super fun parts of algebra 2 trig. I miss this, and then I miss logarithms. Oh boy. Okay, so 15, 16, and 17 are from the log chapter. Yeah, I need to change these to the same base. Yes, why? 3 to the, what's the other one? Yes. Okay, so on 15, they can have the same base, which is awesome. God bless you, Angel, for that. And then we discussed on Friday, when we are raising to a power, we multiply the exponents. So I've really got 360 plus 2, because I distributed, equals 3 9c minus 3. They have the same base, so I can actually get rid of them. Forget the bases. Really, we just need to see what exponents need to be equal to each other. So 6c plus 2 equals 9c minus 3. I always thought it was so weird, and then you just ignore the bases. But, I mean, they do match, so I get why you ignore them, but it just seems weird. Okay, and then subtract 6c. 2 equals 3c minus 3. I add 3 to both sides. I get 5 equals 3c, so I end up getting 5/3 equals c. So it's weird because I end up getting a fraction, but that's okay. But again, even if Paige has forgotten all this, Paige is smart and thinks they're multiple choice. She can plug in the weird answers, use her calculator, and figure out if I plugged in 5/3 into that C spot and I get some number for this one, I plug in that 5/3 into this one with the 27. If I get the same number, then that must be the answer. She's smart. She can figure this out even if she doesn't know what she's doing. Okay, and then the coolest thing ever is that 16 and 17 can be done in your calculator. But I heard y'all don't know how to put it in there, which is fine. We can fix that now. Logs are a pain in the tail if there's an X, and there are a lot of rules, and they really are a pain in the rear, I'm not going to lie. But if they're like this with no variables, we can put them, we can put them in our calculator, which she already knows how to do. Darn, she's good. Never mind, I do have my own. Okay, so if you've not noticed, there is a log button, but when you press the log button, it doesn't do the tiny number. So instead, if you press math and then scroll down, there's one that says log base. So I pressed math, I scrolled down, and there's one that says log base. I hit enter, and oh look, I can type it all in now. So my problem was 381. Oh, the answer's 4.
Mine doesn't have that. Look at it.
Do you have a math button?
Yeah, I do, but I don't have that.
You don't have log base? Show me yours. You an 84 as well? You've got 2 logs. Look at your problem and you've done log. finish my life and then I'll figure it out. Because surely there's a button, because yours is even fancier, so there has to be a button. Okay, and then for the other one, same thing, math, log base 2 of 1 over 32. And I get -5. So the answers are 4 and -5.
Yeah, did we just show you the maze or did we just turn it in?
I want to see it, but now is the second. Show it to me when I look like I'm not about to cry, which might not be until Wednesday. Okay, are there any questions about this? Then let's look at your notes for today, and I'll try to use as few words as possible because I swear to goodness my words are not coming out well today. On Friday, we were discussing, well, we've done right triangle trig, the sine, cosine, tangent, cotangent, secant, cosecant. And we want to know what to do with that in life. Like, okay, now that we know those, what can we use it for? And it's going to be used with something called the unit circle, which helps us with everything pretty much in trig. And sad day, I don't even know that we're going to get to the unit circle. So if I were you and I was going to go on to a pre-calculus or any other higher math class, I would learn the unit circle over the summer. Just my 2 cents, because your teacher's going to expect you to know like sine 30 is 1/2 off the top of your head kind of thing. But it's okay if you don't. You won't die. But the important thing is to know how to read a unit circle, and how to read is to understand how the degrees are working. So we discussed on Friday that if we have an angle, let's say it's drawn here, when we're wanting to read the angle, we don't actually go clockwise. To read the angle, we go counterclockwise. We discussed if we went the full way around the coordinate plane, we would have gone from here all the way back around. We've gone 360 degrees. So this spot right here is 0, but yes, if I go all the way around, I've gone 360 degrees. So it's also 360. We discussed that 360 divided by 4 was 90, so each of these spots are easy to figure out. If you know these main 4 numbers, literally you can figure out most other issues in life involving this. Okay, for instance, right now this angle I've drawn is clearly bigger than 90, but not quite 180, so maybe let's say 110. And that's what we did on Friday, and on the back of the notes from Friday there is a maze, and you follow it around and you practice with it. Which you're going to practice the things I'm about to say, we're just adding a vocab term to it. Okay, so we also discussed on Friday coterminal angles. I didn't call it that then, but we discussed it. We discussed that if they asked you about going negative, let's say they went negative 45 degrees. If they went negative, that means they went clockwise. And if we want to figure out what the equivalent is going counterclockwise, we would just do 360 minus my negative number. 360 minus 45 is 315. So negative 45 degrees and 315 degrees are coterminal. They're basically equivalent. They're marking the same spot. So if I'm trying to figure out the coterminal angles for negative 765 or negative 200, I'll do negative 200. I would just do 360 minus my negative number. And I'm going to get 160. So if I were to draw the picture like I did here, the 160 and the negative 200 are really this exact same angle. They're both at this exact same spot. Okay, we also discussed on Friday that sometimes you could go around more than once. So let's say you went all the way around, and then you went a little more after that. That's what's happening when we're over 360 degrees. So like number 8, number 12, we've gone more than 360 degrees. So you went all the way around 360, and then you went up 15 more to get to that 375. So 375 is here. Let me use a different color. You went around and a little bit more, and that's how you got to this 375 degrees. But really, this spot is the same as the 15 degrees, because 375 minus 360 is 15. So they're marking the same spot. It's like the clock, you know. It goes all the way around to 1 and then goes all the way around again to 1, or whatever time you want to think of.
So if you get 365, what is it at 15?
So seriously, if there's a number bigger than 360, just subtract 360. So like on number 8, it's 620. I would just do 620 minus 360. And I get 260. So 620 and 260 are in the same spot. They're coterminal. They're marking the same spot. And again, if you've tried the maze, you've already been thinking that through in your head, so I'm really not that worried about it. That's mostly for the people who weren't here on Friday or the people who, I don't know, slept this weekend. I don't know. Okay. So again, I'm going to tell you all the cool stuff leading up to the unit circle, and then we're going to run out of time before I can actually really teach you about how to use the unit circle and what it looks like and how they come out with it and all that cool, all the cool stuff we're not going to have time for in life, which is a bummer. I do need to tell you about the bottom of the page. There's something called a radian. The word radian sounds like what part of a circle? Radius. Radius. Now you know where they got it from. Okay, so if you go across the middle here, across that diameter, and we were saying that was 180 degrees, that's exactly 1 pi. And if you go 360 degrees, you go all the way around back to the beginning. That's the same thing as going 2 pi. Now, do you have to know that at this moment in life? No. We eventually need to know how to convert from, in your mind, on this unit circle, how to convert from radians to degrees, like to know that this spot is 90 and also pi over 2. Yes, but at this moment, we're not that big of a deal. All we need to know today is how to convert between the two. So we're either in degrees, like 360 is degrees, or we're in radians. If you're in radians, you're always going to see the pi symbol. So you're like, how do I know the difference? Do you see a pi symbol? If there is a pi, you're in radians. If there is no pi, you're in degrees. So literally, is there a pi? Pi or no pi? I remember in science class spending a lot of time converting between Fahrenheit and Celsius. And like I had to memorize that formula, and it stank because there were like 2 different formulas. Like a 5/9 or a 9/5, and it was a pain. Yes. So, yes. Degrees and radians are way easier than that. Right. And degrees and radians are a little easier than that to me. We're either multiplying by this or multiplying by this. Regardless, there's a 180 and a pi. It's just which fraction do I need? Which one do I need? Okay, so you're going to use this if you want radians. And you're going to use this if you don't want radians. So and you're like, do I need to memorize the 2 then? No, it's literally pretty obvious in life as to which one you want. For instance, there are 2 problems at the bottom, and I'm going to work a couple more than that. If you're given 120 degrees and you're asked to convert that to radians, you're going to multiply by pi over 180 because, like I told you, radians always have a pi in the answer. So I was given degrees, and I want to go to radians. I multiply by pi over 180. So I get 120 pi over 180. I'll come back and simplify that in just a second. Let's say I wanted to do 100 degrees to radians. I would also multiply by pi over 180. So I get 100 pi over 180. Now what's weird about radians is that they're always, not only do they always have a pi, but they're always in fraction form. So if I type in 120 divided by 180, I know I get 0.67, but I can't put 0.67 pi. They don't like that. They're never given that way. They're always given as a reduced fraction. So I do have to reduce it, and it reduces to 2 pi over 3. If you've forgotten how to reduce a fraction, you can type it in and get the decimal, and then press Math Frac to go back to a fraction, if you need to do that. Okay, so on my other one, it reduces to, I don't know, so I'm going to do 100 divided by 180. I I get 0.56, but again, they don't want to see 0.56 pi. Your answer choices, or anytime you're asked about radians, it's always going to be in a fraction. So math frac, and it's 5 pi over 9. So we went from 100 degrees to radians. 100 degrees is equivalent to 5 pi over 9 radians. 120 degrees is equivalent to 2 pi over 3 radians. So we've gone from degrees to radians. We've got to be able to go the other way as well, which, duh, of course, that makes sense in life. We have to go from radians to degrees. All we want to do then is get rid of the pi. So, for instance, let's say we have pi over 6, and then they gave you one of 3 pi over 8. So let's do 2 of those. If I'm wanting to get rid of the pi, that's when I would multiply by 180 over pi. I need pi's to cancel out. Okay, so with this one, I end up getting 180 divided by 6, which I think is 30, but math is hard. On this one, I get 540 over 8, which is 67.5, which is fine, because degrees don't mind decimals. It's radians that are picky about them being fractions. So I know Cooper's like, I'm about to leave. I don't need to know this in life, and I understand, but I swear to goodness, whatever math class you take next is going to ask you about this. So if you're ever asked to convert, you're either using pi over 180 or 180 over pi. It just depends. Are you trying to get a pi in your answer? Are you trying to get rid of the pi in your answer? Okay, so if Cooper was a genius and he wanted to practice this, there are some practice problems on the top on the back. It is not a grade. He does not have to if he does not want to. He eventually does have a test, but like I said, it's on Google Classroom, so he can use Google, and I'm even going to leave a note that he can talk to whoever he needs to talk to, whatever. I just need Cooper to do things. I understand life is hard. Trust me, I'm there. So there.